In this video, I am going to solve the problem 13 from chapter 26. Nichrome wire consists of a nickel chromium iron alloy, is commonly used in heating elements such as on a stove, and has a conductivity 2 multiply 10 power 6 per ohm meter. If the nichrome wire with a cross-sectional area of 2.3 millimeter square carries the current of 5.5 ampere when a 1.4 volt potential difference is applied between its end, what is the wire's length? So in this question, we are going to find what should be the length of the wire. So for that, they clearly mentioned the material used in the wire is nichrome wire, which is the alloy of nickel chromium iron material, and its conductivity value is given because we studied in the theory conductivity has the inverse relation with the resistivity, right? So that value, conductivity value, is given here as 2 multiply 10 power 6 per ohm meter. And also they mentioned the potential applied across its ends of the wire is 1.4 volt, as well as the current mentioned as 5.5 ampere, and also the cross-sectional area detail is given here as 2.3 millimeter square. By using all this information, we are going to find the value of the wire's length. So let's write the given first, and then we just go for proceeding to find the value of the length of the wire. So here the conductivity is sigma, right? So sigma takes the value of 2 multiply 10 power 6 per ohm meter. And also the current information here given as 5.5 ampere, and also the cross-sectional area is given here as 2.3 millimeter square. So if you convert it in terms of a meter square, we have to convert this millimeter to meter first. So 2.3 multiply 10 to the power of minus 3 the whole square, right? Because 1 millimeter is equal to 10 to the power of minus 3 meter, and here square is given. So if you square this value, we will get the answer of the power as 2.3 multiply 10 power minus 6 meter square. So this is the area in terms of meter square. Clear? And also the voltage applied between the ends of the wire is mentioned here as 1.4 voltage. By using all these things, we are going to find what should be the length of the nichrome wire. So for this, again, we have to use the rule of the resistance, which we studied in the theory. Resistance R is equal to the resistivity of the material multiplied by the length of the material over the cross-sectional area of the material. So here we are going to find the length. So I have to modify this equation in terms of length. That means rearrange this equation in terms of length as length is equal to resistance multiplied by area over the resistivity. So here the resistivity value is not given, but we studied the relation between the resistivity and the conductivity. Conductivity has the inverse relation with the resistivity. So therefore, we can write this resistivity as 1 over sigma, that is 1 over conductivity. So in this place, I can write L is equal to R multiplied by area. That means R is the resistance, A is the area, cross-sectional area of this material, over, and in place of resistivity, I'm going to use this. So if you substitute, what will happen? This will become 1 over sigma. And also, we don't have the information about the resistance. So for that, I'm going to use the relation from the Ohm's law. V is equal to IR. Therefore, R is equal to V over I. I'm going to take this R and I'm going to substitute here. If you substitute, this equation will again remodified as L is equal to, in place of R, I'm going to substitute V over I multiplied by A, and this rho will go to the top, right? Multiplied by sigma. Clear? So now I'm going to substitute the value. We have all the information. Voltage is there, current we have, and the cross-sectional area of the wire is given, as well as the conductivity information is given. So now I'm going to substitute the value. So we just read what is the voltage here, 1.4 volt, and the conductivity is 2 multiplied 10 power 6, and the current is 5.5 ampere, and area is 2.3 multiplied 10 power minus 6. So I'm going to substitute the value here. So voltage is 1.4 multiplied with the area, cross-sectional area is 2.3 multiplied 10 power minus 6, and the conductivity value 2 multiplied 10 power plus 6 over the current is 5.5 ampere. If you calculate all these, we will get the length of the wire as 1.17 meter. So this is the answer for this question. That's it. Thank you.